Right then, we finally come to the last panel data model, which is random effects. Let's understand more how does this model differ from pool OLS and fixed effects. Okay, this is the command to run the random effect model. We can see that the random effect estimation also uses xtrect command just like fixed effect estimation. Xdirect y x1 comma re. At the end here, we write re instead of fe, which means that we want Stata to estimate a random effect model for us now and not fixed effect. This is the random effect estimation result that we're gonna get once we run the command above. Firstly, look at this correlation between ui and x, and it is assumed to be equal to 0. Just a side note, Stata generally calls unobserved heterogeneity factor by the name UI. This is equivalent to the VI in our model earlier. Recall that in fixed effect estimation, fixed effect model gives some value to the correlation between UI and X. But here in random effect, it is assumed to be 0. So please note that this is actually the key difference between random effect and fixed effect estimation. So we will learn more about this later. Another interesting finding is that RE estimation yields different coefficient estimates of the beta 1 for the regressor X1 here. This is again due to the different assumption between fixed effects and random effect estimations about the unobserved heterogeneity factor. So let's now hit to Stata to run the command. So we write xtrect y x1 comma re and press enter. So we get the identical result that we saw just now. So we can also run xtrect y x1 comma re and put theta word at the end there to know the value of theta. So the value of theta is 0.36. So we will learn more about theta in the transformation process of the random effect model. So let's go back to the slide. Next. To understand the random effects estimation, let's just read the statement here from the green textbook, page 183. The crucial distinction between fixed and random effects is whether the unobserved individual effect embodies elements that are correlated with the regressors in the model, not whether these effects are stochastic or not. In other words, this paragraph clearly shows that fixed effect model assumes VI, or the unobserved heterogeneity factor, is correlated, is present and correlated with the regressors. But in random effect model, it is assumed to be present only and not correlated with the regressors. Remember, just now we look at the correlation between UI and X. So some values of correlation in fixed effect estimation result, and for random effect estimation result, it is assumed to be 0. Therefore, the key assumption in random effect model is that the unobserved heterogeneity factor is present and it happens randomly and not specifically belonging to the entities or cross-sectional units in the data. This is equivalent to the individual invariant factor that we discussed earlier, like the international agreements, national policies, or macroeconomic factors that exist in some periods within the sample data and applicable to all countries in that particular periods. So this is important. You must use random effect estimation if you have reason to believe that your data have elements of individual invariant factors. So your data have differences across entities that influence your DV, but they are not correlated to the IVs or the regressor. Now we come to the transformation process of random effect model. The transformation takes the equation 3 and minus it with a fraction of average equation, which is the equation 4. In other words, random effect estimation only eliminates a fraction of the average data, unlike the fixed effect estimation that completely removes the average data from the original observations. Theta here specifies the size of the fraction. The value of theta, if it is equivalent to 1, it means that it is a complete deviation from mean transformation. Hence, RE or random effect model will be identical to the fixed effect within estimation model. But if theta equivalent to 0, then we don't do anything with the original data. The average value of y or x here is not exist. So we don't do anything with the original observations. Hence, we simply run estimation on the original observations, meaning that it is a pool OLS estimation. Again, in random effect estimation, the transformation is rarely done manually because we never know the value of theta. Hence, we just run extract command and Stata automatically transforms the data using the value of theta that it computes automatically based on the dataset observations that we load into the Stata. So that is all about the random effect model. And one thing that you must remember is the key difference between random effect model and fixed effect. Random effect assumes the presence of unobserved heterogeneity factor, but it is not correlated with the regressors. But in fixed effect model, it assumes the unobserved heterogeneity factor to be present and correlated with the regressors.